The focus of this lesson is on graphing a quadratic function, and the procedure is pretty straightforward for graphing quadratic functions. So you would first find the vertex of your function, and you would determine if your function opens up or down, and then you would plot 2 points additionally beyond your vertex, one to the right and one to the left of the vertex. So that's basically the procedure. So let's go ahead and look at our function f of x equals 4 times x minus 2 squared minus 3. So we can see from looking at that equation, it's in standard form. So the vertex is actually obvious to us. So remember, the formula says a times x minus h squared plus k, and recall that hk is your vertex. So our vertex would be who's being subtracted off from x. That's our h values, so in this case it's 2. And then what value is being added to that square piece? And you can see negative 3 is being added in. Kind of opposite of what you see for the x-coordinate, exactly what you see for the y-coordinate of your vertex. So we can go ahead and plot to negative 3. That's our vertex. But then our a value, we can see, is a positive 4. And the significance of the positive is that means our graph opens up. So then we know that our vertex, if our graph opens up, we know our vertex is a minimum. So then now all we need to work on is getting some additional points, one to the left and one to the right, and we'll have completed our graphing. So we already have the point 2, negative 3. That was our vertex. So to the left of 3 would be 1 unit to the left of 2. So we need an x value of 1. So what happens when x is 1? Well, f of 1 is 4 times 1 minus 2 squared minus 3. So we need to do that evaluation. So 4 times negative 1 squared minus 3, but that's just 4 times 1 minus 3, which is just 4 minus 3, which is 1. So we get the ordered pair 1, 1. So that's another one of our points, and that's the one directly to the left of the vertex. So 1, 1. To get a point to the right, we need to go 1 unit higher. And so 1 unit high would be at 3. And then if we want to get the y value, and I'm just going to, again, just label this so you know where it came from, but the y value would be whatever f of 3 is. So let's figure out what f of 3 is. So f of 3 is just 4 times, wherever there's an x, put in 3. And then everybody else remains the same as originally in the equation. So this is 4 times 3 minus 2 is 1 squared minus 3. And it's 4 times 1 minus 3, so 4 minus 3 is 1. And we actually would expect to get, if we move the same distance from our vertex, like so 1 whole unit away to the left, and then we move 1 whole unit away to the right, because there's symmetry across the axis of symmetry that goes through the vertex, we would expect to get the same y value back, and we do. So when x is 3, y is 1. And then this does open up like we expected. Notice it's kind of U-shaped, and again that should go all the way down, so I don't have a perfect drawing here, but you get the idea. So that is our graph of our quadratic function. And then as far as the domain goes, well, for quadratic, the domain's always all real numbers, but you can see that. You can see as you go from left to right, every x is accounted for. Whereas for the range, it's going to start at, in this case, your low point. So, and it's going to include that point. So it's going to be your k value, which in this case was negative 3. If you had labeled that, it'd be more obvious. And then it's going to go all the way up to infinity. So that gives you your domain and your range. So that's graphing a quadratic function.